Hello everyone, welcome to the session of Fluid Power System. So I am Purushottam, working as Assistant Professor in the Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. Today's session is about pressure control valves and its classification and construction and working of some important pressure control valves. So before moving on to what is pressure control valve, so we have to know why these pressure control valves are used. So the pressure control valves are those which is used to control the pressure of the fluid in a hydraulic system. That means if you want to control the pressure of the fluid in a circuit, then we are going for pressure control valves. The main function of the pressure control valves are, the first one is the limiting the maximum system pressure to safety measure. For example, if the system pressure, the maximum operating system pressure, which is 20 psi, if it is exceed that 20 psi value, then that will cause the damage to the components in the hydraulic system. In that case, the pressure control valves which is used to limit that pressure in that region, that is, so if it is exceeding 20 psi, then these pressure control valves which is going to operate and control, limit that value within or which is equal to the 20 psi. That is the first one. Then the second one, which is used to regulating or reducing the pressure of the fluid in any portion of the hydraulic circuit. So in whatever portion of the hydraulic circuit, in that region we can regulate or reduce the pressure of the fluid by using this pressure control valve. Then we can also use unloading of pressurized fluid by using this pressure control valve. Then assisting the sequential operation of actuators by using pressurized fluid. That means if you want to do some sequential operation, the operation which is in the order of, first we have to do some clamping process, then we have to do some machining process, then this process can be assisted by varying the pressure of the fluid by using this pressure control valves. Then finally, whatever the operations which is related to pressure, then we are going to use for pressure control valves. Next, coming to the classification, so based on the primary function, so based on primary function of pressure control valves, they are classified as the first one, pressure relief valve. Under this we can see two types. First one is direct acting pressure relief valve. Then second type is pilot operated pressure relief valve. Then the second classification is, so pressure regulating or reducing valve. Then the third one is pressure unloading valve. Then fourth one is pressure sequencing valve. Then the fifth one is pressure counterbalancing valve. Okay. So based on the primary function of pressure control valves, we are going to classify it as pressure relief valve. Under this we are going to study direct acting pressure relief valve, then pilot operated pressure relief valve, then pressure regulating or reducing valve, pressure unloading valve, pressure sequencing valve, pressure counterbalancing valve. So now let us study one by one. So the construction and working of these valves. As I told, the main function of the pressure control valves are limiting the pressure, unloading the pressure, as well as sequencing the operation, as well as then regulating the pressure. Based on these main functions, we are classified. We can see these types of pressure control valves. Now let us see one by one. The first one is pressure relief valve. Pressure relief valve. So the pressure relief valve, which is nothing but a safety valve, which is usually normally closed valve. So these pressure relief valves, which is normally closed valves. That means the pressure, the fluid which is not going to enter this valve. So when the inlet pressure which is within the prescribed limit, then the fluid which is directly go to the system, which doesn't go into the valve. Normally closed valve. Normally closed valve. So commonly these pressure relief valves, which are commonly used in hydraulic systems. Commonly used in hydraulic system. The main function of the pressure relief valve is limiting the pressure of the system to the maximum prescribed pressure by delivering some or full output of the pump to the tank. That means if the maximum pressure of the system is around 30 psi, if it is exceeding that 30 psi, then what will do, this pressure relief valve, which is going to divert some part of the fluid or all output from the pump to the tank. This will be the function of pressure relief valve. Under this, as I told before, we can see two types. First one is direct acting pressure relief valve, and second one is pilot operated pressure relief valve. Now let us see the direct acting pressure relief valve. So this will be the casing. This will be the casing of the pressure relief valve, which contains puppet or ball. So this will be the puppet or ball as a valving element, which is held in position, which is held in its seat by using spring pressure. This will be the spring pressure. So that means this is going to close this valve. This will be the adjusting screw. So by using this screw, we can adjust the prescribed pressure. For example, system pressure is 30 psi, then we can adjust the system pressure 30 psi by using this knob. That means while turning this knob, we can adjust the pressure. That means while turning this one, this will forms the spring force. So that spring force which is equal to 30 psi. For example, 30 psi. So adjusting knob. Then what will happen? So here in this case, here we can see the inlet pressure. So when the fluid which is going to enter this valve, which is below the prescribed pressure, or equal to the prescribed pressure, around 30 psi means if the system pressure is 30 psi or below that, around 29 psi or 28 psi, then this valve which is going to remain closed. Then what will happen? The fluid from the pump, which is directly going to the system. The fluid which comes here, so this puppet which is closing this valve, then the fluid which is going to the system. When the prescribed pressure, the system pressure which is going to exceed the prescribed pressure, that is the system pressure which is around 31 psi. For example, the prescribed pressure is 30 psi, the system pressure which is around 31 psi, that means which is exceeding the prescribed pressure, then what will do, this fluid which is going to force to open this puppet. Then the fluid from the pump which is going to flow between the seat and the puppet, and which is going to the tank through the outlet port. So this one, so the pressure at which the valve which begins to open, which is called as cracking pressure. cracking pressure. The pressure at which the valve which is begins to open, which is called as cracking pressure. So once the puppet which starts to open due to the flow of the fluid, the puppet which opens fully. The puppet which opens fully. So that means the fluid from the inlet port which is discharged to the tank through the outlet port. So that means the pressure at which the valve fully opens, which is called as full flow pressure, That means the valve is completely open, so whatever the fluid from the inlet which is going to enter the tank through this outlet port. Then the difference between the cracking pressure and full pressure, which is called as pressure override. The difference between the cracking pressure and full flow pressure, which is called as pressure override. So what will happen in direct acting pressure valve? When the inlet pressure or system pressure which is within the prescribed pressure, this valve remains closed. Then the fluid which is going to enter the system. When the inlet pressure or system pressure which is exceeding the prescribed pressure, then the puppet will force to open, then fluid from the inlet which is going to enter the tank through the outlet port. Okay. So this will be about direct acting pressure relief valve. Next we move on to pilot operated pressure relief valve. So what is the need of this pilot operated pressure relief valve? So the pressure override, this one, that is the difference between the cracking pressure and full flow pressure. So this will be called as pressure override. So this will result in the wastage of power due to, so the pressurized fluid directly flow to the tank before attaining the maximum prescribed pressure, due to which the power will be lost. To minimize this pressure override, we are going for pilot operated pressure relief valve. Which is also called as compound pressure relief valve. Okay, which operates in two stages. The operation of pilot operated pressure relief valve, which is in two stages. The first stage which contains the main valve. So this will be the main valve. The main valve which contains a puppet with a piston, which is held in this position, by using spring force. The puppet which is held in this position. Then the piston which is having orifice. This main valve, this will be called as main valve. This main valve which allows higher flow rate, through this valve. Then the second stage is pilot pressure relief valve. This will be called as pilot pressure relief valve. You can see here. So this will be the puppet which is held in position by using spring force. This will be the adjustable screw or knob. So by using this adjustable screw, we are going to set the prescribed pressure of the system. By using this knob. So what will happen? So this will be the inlet port. This will be the port which connects to the tank. So when the system pressure, that is the fluid which is going to enter the valve, then what will happen? The fluid which flows through this orifice in the piston, orifice in the piston which enters here, pilot relief valve, which enters here when the system pressure is less than the prescribed pressure. System pressure is less than the prescribed pressure, this valve which remains closed. This valve remains closed. So hence what will happen? Then what will happen? The fluid which is going to enter the system. Just because this will be the closed one. Here also the puppet is closed. Here also the puppet is closed, blocking the valve. So there is no place for outgoing outlet. So hence again the fluid which is going to the system. So when this blocking, that means here there is some fluid on the upper portion of the main valve. So the pressure on this upper portion of the main valve which is equal to pressure here, the system pressure. Then only both will be blocking. So both the pressures are same, then this will be blocking the puppet, blocking the valves. So when the pressure which exceeds the prescribed pressure, system pressure which exceeds the prescribed pressure, then what will happen? So this puppet which is going to open, this puppet, so the fluid will comes here through the orifice which is going to enter here. When the system pressure is more than the prescribed pressure, this puppet will open, then the fluid will enter this valve, and through this channel which is going to the tank, So that means there is a pressure drop. Now the pressure in this main valve is less than the inlet pressure. So there will be a creation of pressure difference. So when the pressure difference is more, what will happen? The pressure of the fluid which is going to move this piston upwards. When the piston which moves upwards, this puppet valve which opens. This puppet valve which is going to open, which is also lift, which is going to open. Then whatever the fluid from the inlet which is going to enter the tank through this port. So whatever the fluid which is coming from the inlet which is going to enter the tank through this port. So that means when the system pressure is below the prescribed pressure, the valve will be closed. The fluid which is going to enter the system, which is exceeding, there will be a pressure difference between the valve and the system pressure. Then the pressurized fluid which is going to push or move upwards this piston, then the valve will be open. Then the fluid which is going to enter to the tank in the pilot operated pressure relief valve. This pilot operated pressure relief valve which is compact as well as which is used for high pressure and high flow rate applications. So next we move on to the pressure regulating or pressure reducing valve. So here this will be the casing of this pressure regulating or pressure reducing valve. This will be spring loaded spool. So this one is spool. So which is spring loaded. So the spool which is held in position by using the spring force. Then here also we can see the adjustable screw. By using this adjustable screw, we can adjust our prescribed pressure of the system. We can give the prescribed pressure of the system. This will be the inlet port. So this will be from main system. From the main system, the fluid will enter to the inlet port. This will be the outlet port. Then there will be a connection between outlet port to the spool end. This will be spool from outlet port to the spool end through the passage. That means whatever the pressure in the outlet which can be transferred to the spool. So this one, pressure reducing or pressure regulating valve, which is normally open valve. That means, so the fluid which is coming from the main system which is going to the outlet port normally. when this valve is activated, then which is going to close this outlet port, Now here when the fluid enter from the main system which is going to the outlet port, so that means the system pressure which is less than the prescribed pressure, then whatever the fluid from the main system which is going to the outlet. When the system pressure which is exceeding the prescribed pressure, or in the outlet there is some resistance, there will be some resistance in outlet circuit, so that will create a backup pressure. That means the pressure at the outlet which increases. So that will which in turn transfer to this spool. Then what will happen? The spool which is going to move towards the spring. This will be the first position. So when the outlet pressure is increases, that will create the backup pressure. So that is going to transfer to the spool through this passage. Then the spool which move towards the right side, then the spool which comes here. Now the spool is here, which move from this position to this position. Now you can see the spool which partly blocks the outlet port. So now which is fully open, now the spool which is partly block the outlet port. From this, so whatever the fluid from the inlet port which is going to constrain to move from this port, so this will regulate or reduce the pressure. So which is going to partly block the outlet port from this. So whatever the pressure which is coming from the inlet, which is going to reduced or regulated by using this portion. If this outlet port is completely closed, so in the outlet portion the pressure is too high, when the spool is moved further, outlet portion is completely closed, then there will be some leakage. In the system, so that will build the pressure in this system. To prevent this, the leakage oil that has to be flow to the tank through this channel, which is called as bleed oil passage. Okay. So what will happen? So this will be normally open valve, that is when the fluid from the inlet which is going to enter the outlet, when the prescribed pressure is, or the system pressure is less than the prescribed pressure. When the outlet pressure is more than the prescribed pressure, which is going to move the spool towards right, that is going to block partly the outlet port. From this, the pressure will be regulated. Next we move on to the pressure unloading valve. So here the pressure has to be unloaded, that means the fluid has to be unloaded at low pressure by using this pressure unloading valve, while the pressure relief valve which utilizes the entire system pressure to unload the fluid to the tank. But by using pressure unloading valve, we can unload the fluid to the tank at low pressure. Okay, this necessity of pressure unloading valve arises when the two pumps which are operated under the large volume of oil at low pressure. So in that after some sequence of operation, one of the pump, that is one of the fluid in the pump that has to be unloaded, then the small quantity of oil which has to be discharged at high pressure. So in that case, we are going to use the pressure unloading valve. This will avoid the heat generated in the system. So this will be the schematic representation which shows the pressure unloading valve. If you can see this, so which contains the primary port, this will be from the pump. This will be from the pump. This will be the secondary port, this will be connected to the tank. This will be the port which is connected to the system. So which comprises of a spool and piston arrangement. Spool and piston arrangement which is held in position by using the spring force. By using the spring force. So by using this adjustable knob or screw, we can set the prescribed pressure of the system. We can set the prescribed pressure of the system. So when the system pressure which is less than the prescribed pressure, what will happen? So the fluid from the pump which is going to enter through the wall and which is discharged to the system. So when the system pressure which is greater than or excess of the prescribed pressure, then which is sensed by external line due to which the spool movement will takes place. So which in turn creates a passage in the secondary port. So that means, so when the pressure in the system which exceeds the prescribed pressure, what will happen? So this will be the external line from which the fluid will enter. So due to the pressure of fluid, the piston which move upwards, so due to which the spool movement will takes place. Then which creates passage to the secondary port. That means the fluid from the primary port which is going to enter the secondary port, through which the fluid which is going to discharge to the tank. That means when the system pressure is within the prescribed pressure, the fluid from the primary port which is going to enter the system. When the system pressure is excess of or exceeding the prescribed pressure, so the external line will sense this pressure, from which the fluid will pushes the piston, due to which spool movement will takes place. The fluid from the primary port which is going to discharge to the secondary port to tank. So this will be about pressure unloading valve. Then pressure sequencing valve. The next one is pressure sequencing valve. This pressure sequencing valve is used when the operations that has to be carried out in definite order or in a sequence or one after the other. For example, if the operations, so I will consider two operations. So in the first operation I have to clamp some job. In the second operation I need to go for some machining operation. That means, for example, I will consider a sheet metal, so that has to be clamped in the first operation, first sequence, so which is followed by some machining operation like bending. So here, so in this, here also this which is consists of a knob. So by this we can adjust the pressure, prescribed pressure. Then so which is having a piston which is attached with the spool which is held in position by using the spring force. So this will be the primary pressure line which is followed to direction control valve. Then this will be the to the secondary system. So when the system pressure or primary pressure line pressure which is less than the prescribed pressure, then what will happen? The fluid which is going to enter to the direction control valve. So from that, the clamping of the sheet metal which carried out. Then that has to be held in that position only. So when the clamping of the sheet metal which is carried out, then that will create the back pressure. The pressure in the outlet which increases. Then here we can see the pilot line. So this pilot line. So that increase in pressure which is transferred to the piston from this pilot line. Increase in pressure transferred to the piston from this pilot line. So that is going to move the piston upwards, which in turn opens the secondary port. That means when the system pressure which exceeds the prescribed pressure, then that back pressure which is going to move the piston upwards, then spool movement will takes place. Then so which is going to the fluid which is going to transfer to the secondary system. That secondary system, that means the second operation is to bend the sheet metal. So here continuously the fluid which is going to transfer to the direction control valve, that has to be clamped the sheet metal. In the meanwhile, due to the back pressure, the piston movement takes place, due to which the fluid which is also entered to the secondary system which causes the bending of the sheet metal. So by using this we can carry out the sequential operation in hydraulic circuit. So next we are moving on to the last one, that is pressure counterbalance valve. Pressure counterbalance valve. These pressure counterbalance valves are used in the vertical cylinder to prevent the falling due to its weight or due to the gravity, which consists of the primary port. So this will be the, I will call this as primary port, which is connected to the lower end of the cylinder, and this will be the secondary port which is connected to the direction control valve. This will be direction control valve. So then from direction control valve which is connected to the upper end of the cylinder. So here, so that means when which is used in vertical cylinders, due to the load descending, so that has to be smooth. So if you are not using this counterbalance valve, what will happen? This motion is very odd, which is going to damage the cylinder and which increases the pressure and which will cause damage to the other components in the hydraulic system. So for this we are going to use the counterbalance valve. Here what will happen when the pump which is going to discharge the fluid, the direction control valve which is going to transfer to the upper end of the cylinder. Now the piston at this place, which is going to push the piston downwards, so then the fluid present here in the piston rod end side, which is going to travel through this primary port, and which comes here. Then here the check valve is used, which is closed. Then there is no space for the piston movement, there is no space for the fluid to go out. Then what will happen? Back pressure will create it. So the fluid in the pilot line, which is going to move the piston upwards, which will create passage between a spool and the secondary port. Then the fluid which is going to enter the direction control valve and to the tank. So while raising the load, this is about the lowering the load. So this will be smooth operation. While raising the load, what will happen? The fluid from the pump, which is going to enter the secondary port through the direction control valve. So when the fluid comes here, so which is pushes the check valve downwards, then the fluid which is going to enter here, then through the primary port which is going to enter the lower end of the cylinder. So from which the load which is going to rise. So by using this counterbalance valve, we can easily lower the load smoothly. So by using this, we can avoid the damage to the cylinders. Okay, in this session, we are learnt about the pressure control valves, classification and construction and working of some important pressure control valves. Thank you.